There's this kind of hidden code that connects things all around us. It's there when you're timing a run on the track, it's there when you're buying apples at the grocery store, it's even in the recipes you follow. Today, we're going to crack that code.
Okay, let's just jump right in with a puzzle. If Tom runs 1/2 a mile in 1/4 of an hour, what is his speed? Now, right away you see those fractions inside of a rate problem and you're probably thinking, ugh, this is going to be a headache, right? But what if I told you there's a really simple key to unlock it?
Yeah, I get it. It totally looks complicated. Fractions can do that. But trust me, we're about to use a tool that makes problems just like this, honestly, super simple.
So the very first thing we've got to find is something called the unit rate. It sounds fancy, but it's a really simple idea. All we want to know is how much of something happens in just one unit of something else. In our case, how many miles does Tom run in one single hour?
And here it is. Our secret weapon for this is called keep, change, flip. It's this awesome little 3-step trick for dividing fractions. So first, you keep that first fraction, 1/2, exactly as it is. Don't touch it. Then you change the division sign to a multiplication sign. Easy enough. And finally, you flip that second fraction, 1/4, completely upside down, so it becomes 4/1.
And boom! Just like that, our tricky division problem is now a way easier multiplication problem. All we do is multiply straight across. 1 times 4 is 4 on top, and 2 times 1 is 2 on the bottom. So we've got 4/2.
And 4 divided by 2 is, well, it's 2. So there's our answer. Tom's speed is 2 miles per hour. That's it. That's our unit rate. Pretty simple, right? But hang on, because the answer itself isn't even the most interesting part of this whole thing. Okay, so we got the number 2, but what's so special about it? Why are we making such a big deal? Well, because it's way more than just the answer to a math problem. It's actually the key that unlocks a much, much bigger idea.
This is where our little number 2 gets its fancy official title. It's called the constant of proportionality. Sounds super serious, I know. That's why we usually just call it K for short. And the key thing to remember is it's the number that never changes in this relationship.
And this is maybe the most important takeaway of this whole thing. The unit rate we found earlier, and this constant of proportionality, K. They might sound like two different things, but they're not. They are the exact same idea, just two different names for the one number that's driving everything.
And this constant, this K, is the master key to a super powerful little piece of code, a formula that basically acts as the blueprint for all proportional relationships. And that code is y equals K times x.
Okay, so let's quickly decode this formula. Y equals kx. Think of it like this. Our K is that constant, right? The 2 miles per hour that never changes. X is what we call the independent variable. It's the thing you can change, like how many hours Tom decides to run. And Y is the dependent variable. Its value totally depends on what X is. In this case, it's the total distance he travels.
And this is where it gets really cool, because you start to see this code absolutely everywhere. On the left, you have Tom's running problem. Distance equals 2 times the hours. But look on the right. If you're at the store and apples are $2 each, the formula for your total cost is cost equals 2 times the number of apples. Do you see that? It's the exact same structure, the same y equals kx code, just running two totally different situations.
Exactly. Let's just pause for a second. We started with what looked like a really messy fraction puzzle, and we followed it all the way to this super simple, elegant formula. Y equals kx. What does that tell you? It shows you that a lot of the time, behind something that looks really complex, there's a simple, powerful rule making it all work.
So I'm going to leave you with this question. The next time you're, filling up your car with gas, or following a recipe, or even figuring out how much to tip, just stop and think for a second. Can you spot the code? Can you find the y equals kx relationship hiding in plain sight? What's the K, that secret constant that's running the whole show? I bet you'll be surprised just how often you